This week we've been talking about inequalities. An inequality says that two values are not equal. We have several different symbols that tell us when two values are not equal. The first we're going to talk about is the not equal sign. It looks like an equal sign, but it has a slash through it to show you that the values are not equal. Then we have greater than, less than. If it has a line under it, it means greater than or equal to, or less than or equal to, depending on the sign. Alright, when reading inequalities, we read this as 10 is greater than 5. We can flip it around. 5 is less than 10. Alright, this is read as x must be greater than or equal to 0. So let's look at this last one. If x must be greater than or equal to 0, some possible values that we could put in for x would be 0, 1, 2, 3, and I could continue to all numbers greater than or equal to 0. Alright, in class we've talked about graphing inequalities on number lines. We use a solid dot when we have greater than or equal to or less than or equal to signs. We use an open dot when we have just greater than or less than. It's not equal to. We're going to look at the example. X is greater than or equal to 6. Alright, I do have or equal to, so I'm going to use my solid dot, and I'm going to put it on 6. Alright, then I need to go to all numbers greater than 6. Just like that. Alright, now we're going to look at x is greater than 0. It doesn't say that it's equal to, so we can only use an open dot. We have to put it right on our 0. And we go to all numbers that are, it says less than. I got mixed up. Less than 0. So all numbers less than 0 would be to the left. Alright, now we have negative numbers. You have to remember with negative numbers that the larger the numbers, the closer they'll be to 0 on the number line. So we can imagine that our 0 is over here in front of the negative 1. I have negative 5. I have an or equal to sign, so I'm going to use a solid dot on negative 5. I want all numbers larger than negative 5, so I'm going this way. Because negative 4 and all these values are larger than negative 5 because they're closer to 0 on the number line. Alright, when solving inequalities, you undo what has been done to the variable, just like when you solve equations. So the first one we have f plus 5 is less than or equal to 7. So first I've got to do f plus 5 minus 5 to undo the 5. Rewrite my sign. I have to do the same thing on the right side, so 7 minus 5. Our final answer is f is less than or equal to 7 minus 5, which is 2. So f is less than or equal to 2. Alright, now we have 4d is less than negative 8. I have to undo the 4. Because it's next to my variable, it means to multiply. So I do the opposite of multiplication, which is division. And since I divided it by 4 on this side, I have to do the same thing to the negative 8. Okay, so now I'm left with d is less than negative 8 divided by 4. We know 4 goes into 8 2 times, and because I have a negative and a positive, my answer is going to be negative. So negative 2. This is read as d is less than negative 2. Okay, lastly we're going to talk about some real examples of solving inequalities. So I have, you must be 4 feet or taller to ride the roller coaster. So if you must be, we're going to use y for you. And you have to be 4 feet. If you're 4 feet, you can ride it. So you have to be greater than or equal to 4 feet. That would be an example of a real-world situation using inequalities. Let's look at one more. You must be younger than 12 to order from the kids menu. So we're going to use you again. Why? It says you must be younger than 12. It doesn't say that you can be 12. So if you're 12, you're too old. So we're going to do less than 12. All right, very good.